Next topic is addressing. Okay, in TCP/IP protocols, we are using mainly 4 levels of addressing. What are they? Physical address, logical address, port address, and specific address. This physical address is also known as link address, and logical address is also known as IP address. So here we are going to discuss what these different address types are. So I repeat, the 4 levels of addresses used in TCP/IP are physical address, logical address, port address, and specific address. Okay. So these are the addresses in TCP/IP. Different types of addresses: physical address, logical, port, and specific address. Then how these layers are used with different addressing. Okay, the physical address is used by the host to network layer or the data link layer and the physical layer. Logical address is used by the network layer, and the port address is used by the transport layer, and specific address is used by the application layer. Then what are physical addresses? Okay, the physical address, it is also known as link address. Okay, link address is the address of the node as it is defined by its LAN or WAN. It is connected if a computer is connected either to a LAN or a WAN, then there is the connected node has an address. Okay, then that address is included in the frame used by the data link layer. The data frame attach an identification of the sender or the receiver as its header. Okay, so that address is the physical address. It is the lowest level of the address. Then the physical address have authority over the network. Then the size and format of these addresses depend on the type of the network. That if we are using Ethernet, it uses a 6-byte physical address which are printed on the network interface card. Okay, so the physical address is printed on the network interface card. It is the lowest level address and the address used by the node in a network. Okay, then this is an example. That is, the node with physical address 10 wants to send a frame to a node with physical address 87. The two nodes are connected by a link or a bus topology. Then that as shown in the figure, that is, the sender is the node with physical address 10 that is included in the frame. Okay, the source address. Also, the destination address is also included in the frame as 87. Then the nodes are connected to the LAN using a bus topology. Then the different nodes connected are the node with physical address 10, 28, 53 and 87. Okay, so the node 10 wants to send some data to node 87. So these two addresses are included in the frame. So the frame is sent through the bus. Then when it is sent to the first node whose physical address is 28, then the destination address does not match, the packet is dropped. And next it goes to 53. Here also there is a mismatch, so that packet is dropped. Then after that it will reach the 87, node 87. Then it is the correct destination address, so the frame is received here. Like this, the physical address is used in a network, either it is a LAN or a WAN, where the physical address is printed on the network interface card. Okay, then the next one is the physical address format is given. Okay, that physical address, the LAN you see, the most of the LAN, that is the Ethernet topology you see on that is a LAN. It uses a 48-bit physical address written in 12 hexadecimal digits. Two hexadecimal digits is separated by a colon. So a 6 byte or 12 hexadecimal digit is used to represent a physical address. Here the physical address format. Okay, both hexadecimal, that is numbers and alphabets A to F, are used to represent that physical address. Okay, then the next one is the logical address. The logical address is used for the universal communication. Okay, that is independent of a physical network. That is, we cannot send universal network, means that is internet. Okay, that is not meant either a LAN or a WAN. So physical addresses are not adequate an inter-network environment where different networks have different address formats. Okay, so a universal addressing system is imported, in which each host can be identified uniquely regardless of its physical network. So a uniformly accepted address format is used for identifying the nodes in a inter-networking system. That inter-networking system contains different types of network in which different types of address formats are used. So for that purpose, we design the logical address. A logical address in the internet we are using currently is a 32-bit address that can uniquely define a host which is connected to the internet. No two publicly addressed and visible hosts on the internet can have the same IP address. That is, it is unique. No two publicly addressed and visible hosts should not have the same IP address. So here is an example. Here we have different LANs are connected using an inter-networking. So that node, each device has a pair of address, that is logical and physical address. So each the logical address is given as the alphabet and the physical address is given as digits. Okay, so here a center has the physical address as 10 with its logical address is given as A. It wants to send some data to a system whose logical address is P and physical address is 20. Okay, so here the router is connected to 3 networks. So the router has the address of each pair of networks. Okay, so here we have 10A wants to send a data to 20P. So here first it is LAN 1 is connected through the router to LAN 2. At LAN 2, that the data is given for the 1020, then here the physical address changed and it is connected to LAN 2 to the LAN 3 where the original destination comes. So the physical address changes where it changes the router, whereas the logical address remains the same. When it changes from one network to another, then the physical address changes, but the logical address remains the same. Next we have to discuss the port address. Okay. The port addresses, the IP address is the logical address and the physical address are both necessary for a quantity of data to travel from source to destination. Then we discussed or we have seen earlier, the port address is used by the transport layer. Then we have already discussed that the transport layer is dealing with not the source to destination data receival, but it sends the data to the correct process, process to process. So the different computers different processes are running on a computer with some logical or physical address. So the actual address, port address defines the address of the process. The end objective of internet communication is a process communicating with another process. So this port address sends the data to the correct process on the destination address. So here we are using the port sending data to the correct process. So here we have the A, B, C are the processes on the center A, and the J, K are the processes on the receiver. A is the center and P is the receiver. A and P is its logical addresses. Then it sends data. Then that data is A wants to send the data. Then at the application layer, that A data only, what A wants to send. Okay. Then at the transport layer, it adds the port address. The sending port address is small a and the receiving port address is J. Okay. Then at the network layer, the logical address is added. The logical address is A is the sending logical address and P is the receiving logical address. Then through the data link layer, it has been sent. Here the headers are added, which includes the physical address. Okay, the physical address of the process. Then that through sent over the internet to reach until it reached the correct destination. So the physical address is on a same network. We can use the physical address from one source to destination. If you are transferring data over the internet, since it contains different types of network, the physical address is not sufficient. So here we are using a universally acceptable logical address. Okay, in order to identify the source and the destination. Since the logical address identifies only the source and the destination, we imported the port address which identifies the source and destination processes. Okay, so the physical address will change from hop to hop. The logical address will remain the same. Then the port address is a 16-bit address represented by one decimal number. That is a 16-bit port address represented as a one single number 753. Okay. Then next we have one more address, that is specific address. Specific address is the user friendly addresses that are designed for some specific address. For example, the email address and the URL, uniform resource locator. For example, email address, that is ccsid@uoc.ac.in or jmctsr@gmail.com. These are the user friendly addresses in order to identify a specific address. Okay, then the universal resource locator, for example www.uoc.ac.in. These are the specific addresses. So I hope you all clear with the different types of addressing. Physical address, which identifies the address of a node that is imprinted on the network interface card. Then for using a node on an internet, we use the universally acceptable logical address. In order to identify the correct address, we are using the port addresses. Then the specific addresses are user-friendly addresses that are designed for a specific address. For example, are email addresses and uniform resource locators. Okay,